Running generator conductors through a meter socket enclosure to reach a panel board is a code violation. National Electrical Code, or NEC Section 225.37. B states that a switch or circuit breaker shall not be placed in a meter socket enclosure. This code requirement applies to both transfer switches and circuit breakers. The purpose of this requirement is to prevent accidental contact with live parts when the meter is removed or replaced. In the scenario described, the meter is pulled, but there are still hot conductors passing through the meter socket enclosure, or NEC. This is a violation of NEC Section 225.37. B, because it creates a potential hazard to anyone who may come into contact with the energized conductors. The proper way to run generator conductors through a panel board in this scenario would be to use a separate raceway such as conduit or cable that is connected to the transfer switch and runs directly to the panel board. This ensures that the generator conductors are isolated from the meter socket enclosure and any potential hazards associated with it. Let's delve deeper into the specific reasons why this practice is a code violation and explore alternative methods for safely connecting a generator to a panel board. The primary concern with running generator conductors through a meter socket enclosure is the potential for accidental contact with energized parts. Even when the meter is removed, the conductors feeding the panel board remain live, posing a significant risk of electric shock to anyone working on or near the enclosure. The NEC prioritizes safety, and Section 225.37. B is a direct reflection of this concern. By prohibiting the placement of switches or circuit breakers within the meter socket enclosure, the code aims to minimize the likelihood of unintentional contact with live conductors. The meter socket enclosure is designed specifically for the meter and its immediate connections. It is not intended to serve as a junction box or a raceway for other circuits. Introducing generator conductors into this enclosure creates a situation where multiple electrical systems are intertwined in a confined space, increasing the complexity of the wiring and the potential for errors. Furthermore, the meter socket enclosure is typically sealed to protect the meter from environmental factors such as rain and dust. Adding additional conductors or devices to the enclosure can compromise its integrity and reduce its ability to effectively protect the meter. Now let's discuss the alternative methods for safely connecting a generator to a panel board. The recommended approach is to use a separate raceway system that is independent of the meter socket enclosure. This raceway can consist of conduits such as electrical metallic tubing, or rigid metal conduit, or RMC, or non-metallic conduit such as electrical non-metallic tubing, or ENT, or rigid polyvinyl chloride conduit, or PVC. Alternatively, you can use an approved cable assembly that is suitable for the intended application. The raceway should originate at the transfer switch and terminate directly at the panel board. It should be sized appropriately to accommodate the generator conductors, taking into account factors such as conductor size, number of conductors, and ambient temperature. The NEC provides specific guidelines for determining the proper size of raceways and conductors. When installing the raceway, it is essential to follow all applicable code requirements and manufacturer's instructions. This includes properly supporting the raceway, using approved fittings and connectors, and ensuring that all connections are tight and secure. In addition to the raceway, a properly sized and rated transfer switch is crucial for safely connecting a generator to a panel board. The transfer switch serves two primary functions. Firstly, it allows you to switch between the utility power and the generator power, and secondly, it prevents backfeeding of generator power into the utility grid, which can be extremely dangerous. There are two main types of transfer switches. Firstly, manual transfer switches, and secondly, automatic transfer switches. A manual transfer switch requires you to manually switch between the utility power and the generator power. An automatic transfer switch automatically switches to the generator power when the utility power fails. Choice between a manual and an automatic transfer switch depends on your specific needs and preferences. When selecting a transfer switch, it is important to choose one that is rated for the voltage, amperage, and phase of your electrical system. You should also ensure that the transfer switch is listed by a recognized testing laboratory such as Underwriters Laboratories, or UL. The NEC provides detailed requirements for the installation of transfer switches. These requirements cover topics such as location, wiring methods, grounding, and overcurrent protection. It is essential to carefully review and comply with these requirements to ensure a safe and reliable installation. Another important consideration when connecting a generator to a panel board is grounding. The grounding system provides a path for fault current to flow back to the source, which helps to protect people and equipment from electric shock. The NEC requires that generators be grounded in accordance with specific guidelines. These guidelines vary depending on the type and size of the generator. In general, the grounding system should include a grounding electrode conductor that is connected to a grounding electrode, such as a ground rod or a metal water pipe. The grounding electrode conductor should be sized appropriately for the generator's capacity. In addition to the grounding electrode conductor, the generator should also be bonded to the panel board's grounding system. This bonding ensures that all metal parts of the electrical system are at the same potential, which further reduces the risk of electric shock. The NEC provides detailed requirements for grounding and bonding electrical systems. These requirements are complex and can vary depending on the specific application. It is essential to consult the NEC and a qualified electrician to ensure that your grounding system is properly installed. Furthermore, it's important to consider the placement of the transfer switch and generator in relation to the meter socket, enclosure, and panel board. Ideally, the transfer switch should be located as close as possible to the panel board to minimize the length of the generator conductors. This helps to reduce voltage drop and improve the overall efficiency of the system. The generator should be located in a well-ventilated area to prevent overheating and the buildup of exhaust fumes. It should also be protected from the elements such as rain and snow. In some cases, it may be necessary to install a weatherproof enclosure for the generator. Before connecting a generator to a panel board, it is essential to obtain all necessary permits and approvals from your local electrical inspector. The electrical inspector will review your plans and inspect the installation to ensure that it complies with all applicable code requirements. Failure to obtain the necessary permits and approvals can result in fines and delays. Connecting a generator to a panel board is a complex and potentially dangerous task. It is essential to have a thorough understanding of the NEC and all applicable local codes. If you are not comfortable performing the work yourself, it is best to hire a qualified electrician. A qualified electrician has the knowledge, skills, and experience necessary to safely and reliably connect a generator to a panel board. In summary, running generator conductors through a meter socket enclosure to reach the panel board is a code violation according to NEC Section 225.37. b. This practice creates a potential hazard due to the presence of live conductors even when the meter is removed. The proper and safe method involves using a separate raceway system, a properly sized and rated transfer switch, and a properly installed grounding system. Always consult the NEC and a qualified electrician to ensure a safe and compliant installation. Always prioritize safety and adhere to all applicable codes and regulations when working with electrical systems. Remember, electricity is a powerful force that can be dangerous if not handled properly. By following the guidelines outlined in this discussion, you can ensure that your generator connection is safe, reliable, and compliant with all applicable codes. Now let's consider some additional points to provide a more comprehensive understanding. Firstly, consider the specific types of conductors that are permitted for use in generator connections. The NEC specifies the types of conductors that are suitable for various applications, including generator connections. Generally, conductors used for generator connections should be copper or aluminum and should be insulated with a material that is rated for the voltage and temperature of the circuit. Common types of conductors used for generator connections include THHN, THWN, and XHHW. These conductors are typically installed in conduit or cable assemblies. Secondly, consider the overcurrent protection requirements for generator circuits. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. The NEC requires that generator circuits be protected by overcurrent protection devices that are sized appropriately for the ampacity of the conductors. The overcurrent protection device should be located as close as possible to the source of the power, such as the generator or the transfer switch. Thirdly, consider the importance of proper labeling and identification of generator circuits. Proper labeling and identification of generator circuits is essential for safety and troubleshooting. All generator circuits should be clearly labeled to indicate their purpose and voltage. The labels should be durable and weather resistant. Fourthly, consider the requirements for surge protection in generator systems. Surge protection devices are designed to protect electrical equipment from voltage surges caused by lightning or other events. The NEC recommends the use of surge protection devices in generator systems, especially in areas that are prone to lightning strikes. Fifthly, consider the maintenance requirements for generator systems. Regular maintenance is essential for ensuring the reliable operation of generator systems. Maintenance tasks include checking the oil level, changing the oil filter, inspecting the battery, and testing the generator under load. The manufacturer's instructions should be followed for all maintenance tasks. Sixthly, consider the importance of training and education for individuals who work on generator systems. Individuals who work on generator systems should be properly trained and educated in the safe operation and maintenance of the equipment. Training should include topics such as electrical safety, grounding, overcurrent protection, and troubleshooting. Seventhly, consider the impact of local codes and regulations on generator installations. Local codes and regulations may impose additional requirements on generator installations. It is important to check with your local electrical inspector to determine the specific requirements that apply in your area. Eighthly, consider the environmental factors that can affect generator installations. Environmental factors such as temperature, humidity, and altitude can affect the performance of generators. It is important to select a generator that is suitable for the environmental conditions in your area. Ninthly, consider the noise levels associated with generator operation. Generators can be noisy, especially when operating under heavy load. It is important to consider the noise levels when selecting a generator and to take steps to minimize the noise, such as installing a soundproof enclosure. Tenthly, consider the fuel storage requirements for generators. Generators that are powered by gasoline, diesel, or propane require fuel storage. The fuel storage should be located in a safe and secure area and should comply with all applicable codes and regulations. In addition to these considerations, it is important to stay up to date on the latest developments in generator technology and safety standards. The electrical industry is constantly evolving, and new products and techniques are being developed all the time. By staying informed, you can ensure that your generator installations are safe, reliable, and efficient. To reiterate, the practice of running generator conductors through a meter socket enclosure is a clear violation of the NEC and poses significant safety risks. Always adhere to the code requirements and best practices outlined above to ensure the safe and reliable operation of your generator system. If you are unsure about any aspect of generator installation or maintenance, consult a qualified electrician. Remember, safety should always be your top priority when working with electrical systems.